So in the last section, we have understood how to write the code for step turning process in the CNC simulator using the diameter coordinates and absolute coordinate system. In this section, we will be talking about how to work on radial coordinate system. So it's very simple. We just need to go and click on simulate and change the detail settings. The geometry is same as we have seen in the earlier section of the video. We'll just go for radius coordinates here and click on OK. Here, the only change we need to make is we have to divide all the x coordinate here by 2. We'll keep the z coordinate as it is because it is unaffected by the system of the coordinates. You just need to divide the x by 2. So x 16, this would be x 15.5. I'll quickly do this. Um, so we have replaced all the x coordinate. We have divided them by 2. Now we will just click on simulate here. So we will first see the step-by-step execution of the program. It is the same as what we have seen before. So having done with this, we will be going forward to look how the incremental coordinate system is executed in the CNC simulator. So we'll create a new file. The geometry will be keeping the same as we have seen earlier. We'll just we are just required to change the program. So first we won't change anything else, like automatic line numbering will change from 10 to 1 and click on enter. Okay, simulate detail settings. We'll first try this incremental coordinate system with the diameter stuff, and then we'll also see the same with radius coordinates. So the first line will specify the coordinate system, which is incremental. So we'll type G91. G90 is for absolute, G91 is for incremental. The next is the same, G71, which specifies the material removal in the each pass of the turning operation. Then G94, which is for the feed rate. That is also same as before, F100, which is 100 per minute. Then in the absolute coordinate system, we were required to type a locator code so that the the tooltip is actually located at the origin, which is at the center of the circular end face of the workpiece. But in the incremental coordinate system, we need not write it. So we'll just skip to the next part, which is tool M06, T01, then M03. We need to turn the spindle on. M03 is for turning the spindle on in the clockwise direction. And then we need to specify the speed of the rotation in RPM, which is done by using S. And we need a speed of 1000 RPM. So we'll type in 1000 RPM. Then we need to mention the coolant type. So there are two types. One is mist coolant and the other one is flood coolant. We are going with flood coolant, which has a better cooling action. Then, um, then we will just rapidly locate the pointer or the tooltip to the periphery of the workpiece, which is situated here. I'm talking about this point. Actually, it is somewhat offset from the periphery in the Z direction. So we will locate this here somewhere where I've shown, where I've kept the cursor to this point. So the X coordinate and Z coordinate will only change. The Y coordinate doesn't change here. So I'll type X 32 and then Z2. So wherever the tooltip is located before, this code will allow to be relocated at this point. So now because the tooltip is situated at this point, in the next line of code, we will actually mention where else, we will actually mention where to relocate the tooltip to. So in the incremental coordinate system, we need not go with a fixed origin position. So for the next line of code, the system will take this point as a origin. So this point is somewhere here. So this will be taken as the origin, and the top will be plus x, bottom minus x, plus z, minus z. So we need to move the tooltip below. So this will be minus x, and we are required to specify the distance by which we need to move it. So that is x minus 1, because uh, if the origin was located at this point, as in the absolute coordinate system, this distance will be x31. But because the origin is now located here, this distance, we need to specify this distance, which is minus 1. The z coordinate won't change, so there is no need to write that. Okay, z coordinate will also change. We'll mention z minus 2, because we have initially we have placed the tooltip here. We need to move it here, like in the z coordinate, we need to move this way. So this is minus 2. Minus 2 because the origin is now located here. So if we move it minus 2, it will touch the workpiece. Now again G01, we'll move it as per the feed rate uh, till here. After this point of the uh, okay, so at this point, the tool tips is located somewhere here below the periphery, and it is in contact with the circular end face of the workpiece. Now we want to move the tooltip with the feed rate so that it will do its first pass of the turning operation. Now, as we have mentioned earlier, the origin changes in the incremental coordinate system. So this position, the current position of the tooltip, will be the origin. So if we treat this point as the origin, where I've placed my cursor, the pointer, top is plus x, bottom is minus x, right side is plus z, and left side is minus z. So I want to move it in the z direction. I won't be changing the x coordinate. I'm just required to move it in the x direction. So I'll mention z minus 70. Now the tool has moved here somewhere this point. It has performed the turning operation, and the it has removed some material. Now we are required to move the tool back to its starting point. So here we again mention G01, because the tool is somewhere here. We need to lift it to this point. So the tool will be in contact with the workpiece. So we have to mention G01. And now you see this location of the tooltip will be treated as the origin. So if you see, uh, we are only required to change the x coordinate to move it at the top. We won't be changing the z coordinate here. And treating this as the origin, we just need to type x1, because this in the diameter coordinate system, this distance is 1 units. So now the tool has been relocated here, and we are required to move it back to this point. And now the tool will not be contacting the workpiece anymore, so we can type in G00. And now this point is the origin of the tool to move. So we will just we're just required to change z coordinate, not the x coordinate. And since this is the origin and we have to move in this direction, and this distance is 70, we'll type g plus z plus 70, because this side is positive. So the tool, after this point, the tool will be located here. Now we'll again repeat this process. In this first pass, the diameter has been reduced from 32 to 31 mm, and this is the new origin for the tool. So now we again need to move it to 30, from 32 to 30. And because this is the origin and we won't be changing the z coordinate, we'll type in G01 x minus 2, because this is x 32. So if we type in x minus 2, it will move to 30, because this is the origin now. Next, we'll type G01 z minus 70. So after this 10th line, the tool was located here, and now we want to move the tool from this point to this point to perform the second pass of the turning operation. So we'll only be changing the z coordinate in this process, in the turning pass, and this point will be treated as the origin now. So this point, uh, as we will not be changing the x coordinate, and this point is the origin. This is z plus 70. I'm sorry, this will be z plus 70. No, sorry, it's minus 70 only. This side is positive and this side is negative. So this is z minus 70. And next, we have performed a second pass, and the diameter has been reduced from 32 to 30 mm. Then we are required to lift the tool up, G01, and since the tool is situated somewhere here at a depth of depth of 2 mm in the diameter system, so we're required to lift the tool by 2 mm, because this will be treated as the origin and this is plus x axis. This distance will be 2 mm in the diameter system, so we'll write x2. And yes, now we are required to rapidly locate the tool back to the location, back to this location. And because this is the origin now, we will type z plus 70, because this is the plus side, positive side. Now the tool has been relocated back here. Then we can just type G01 and x minus 3, which is 29. Then G01 z minus 70, G01 x 3, then G00 z minus, sorry, z plus 70. So now the tool is located back here, and we have reduced the diameter from 32 mm to 29 mm. We just need to make one more pass to reduce it to 28 mm. So first type x minus 4, and then G01 z minus 70, G01 x plus 4, and G00 x, I'm sorry, G00 z 70. So this ends the process, and we have performed the step turning operation using the incremental coordinate system with diametrical coordinates. Now we need to turn the spindle, switch the spindle off. So the code for the same is M05. We also need to, uh, you know, turn off the coolant. So that is M09. And finally, to end the program, we need to type M02. So with this, we have completed the code for this process in the incremental coordinate system. We click on this option and just check if everything is correct. So the turning process has been completed. The same thing in the incremental coordinate system can be done with radius coordinates as well. What we need to do is we just need to divide everything in the x coordinate by 2. So first we need to change from diameter to radius in the simulate option. Go to detail settings. We'll click on radius. We'll click on OK. And now we'll divide everything by 2 in the x coordinate. This will be 0 0.5, 0 0.5, 1, 1, 1.5, 1.5, 2, 2. So we again click on simulate and see step by step. This is same as before. So nothing has changed. These are just different ways of doing this. So we have completed this now.